Hi friends, this is Sarvajan here. Welcome to my networking channel. Hope all are doing good. Today let us discuss and debug the IPv6 redistribution issues. So here is the architecture where I connected R1, R2 and R3. So R1 I configured RIPng as a routing protocol. So RIP is that is a routing protocol you'll use for IP version 6. And OSP version 3 for IPv6 I have configured on R3. And R2 is a border router. So there should be always one redistribution point for redistributing one routing protocol into another routing protocol. And to R1 and R3, I have connected two different IPv6 hosts. So this host lies in a different subnet and this lies in a different subnet. So PC1 will receive the prefix from R1, this prefix, and PC2 will receive the prefix from this specific interface. So today the issue is for some reason from PC1, I am not able to ping PC2, and from PC2, I am not able to reach PC1. So that is the issue. We need to go and debug the issue. So let us go to the individual configuration. Let us do show IPv6 protocols. So that is the first command always you have to check. This will show the routing protocol. This we are used RIPng is the routing protocol we have configured, and these are the corresponding interfaces. And let us check to R2. R2 is a border router, so it should have both the interfaces. Show IPv6 protocols. So it is showing both the routing protocol OSPF version 3, right? IP is routing protocol OSPF version 3 and RIPng, right? This is a RIP routing protocol. Similar way R3. So R3 will be having the routing protocol OSPF version 3. So as per the architecture we have configured like this. So now let us go to R1 and let us check the routing entry. Show IPv6 route. Show IP route, we'll use it for IPv4, IPv6, show IPv6 route. So we are seeing the directly connected interfaces and the RIP route. We are able to see the RIP route, but we are not seeing this corresponding prefix, right? This both IPv6 address we are not seeing in the specific routing table. So now let us check the directly connected interfaces. One I'm able to reach, this I'm able to reach. Let us see two, and let us ping now this. That is the way we have to troubleshoot :111 : 1. So this interface, specific interface IP, I am not able to reach, right? So that means the issue will be between R2 and R3. So that is the way we can always identify the issue. So R2, the issue lies in the border router. Let us go to R2 and let us check for any passive interface. Or it might be an access list which is blocking. So let us check it out. Show run. So we have to check for always multiple option access list. Yeah, there is an access list block is there. And another best option by doing a show IPv6 protocols, you will have some clues. So here we are able to see, right, there is a route map already configured in this routing protocol, RIPng routing protocol, there's a route map configured. So always you have to check the route map because sometimes the route map might be denying. Show route map, map onto. So map onto we have the deny clause, deny statement, right? So it is matching and there is a deny statement. So that statement is block. So that is, so let us check by access list. Show IPv6 access list. So the access list name is block. You can give the name or you can just directly check. So there is a deny statement, right? So this is denying the specific IPv6 address. So that is the reason I'm not able to see the routing entries in the specific routing table. R1 routing table, I have not seen this routing entry, right? So now let us remove this access list. No IPv6 access list. The name is block, right? And also we have to remove the corresponding route map statement because that is a statement which is denying. So go to configuration mode, no route map onto. So now you removed everything. So now obviously it should come up in the routing table. Let us check now. Show IPv6 route. So still it is not showing up in the routing table. So what we can do, let us go to R2 border router and let us do a show run and let us check it out. So this is the configuration I did. So what we can do, let us do. So let us remove this corresponding route map statement. IPv6 router RIP. So RIPng and let us remove this statement completely. And let us do only this redistribute OSPF 100 metric 10, right? So there should be more than enough. So now let us check the routing entries. Show IPv6 route. So now I think we are able to reach the specific entry. It is showing the destination network, right? This is a destination network. So we are able to see this. Now we will ping from R1 to this destination network. So ping 2001:111:2. So I'm able to reach from R1 to this interface, and R3 let us reach this. So if both are successful, then we should be in a position to ping from PC1 to PC2, right? So let us check from R3, show IPv6 route. So now let us, I'm pinging the destination network. And also it is showing all the routing entries, and you are able to see, right, this RIPng, whenever it is redistributed into the OSP version 3 routing table, it will advertise as OE2. OE2 is nothing but to OSPF. This RIP is an external route. That is the reason it is showing as OE2, right? You are able to identify it, OE2 external route. So these are the external routes. Also you are able to ping the external routes. So now let us ping from PC1 to PC2. Yeah, I'm able to reach, and also from PC2 let us ping. So I'm able to reach from both PC1 to PC2. So now this PC1 to PC2 ping is successful. And another thing I want to show you is this. I already shown about the configuration, how we have configured. So let us now check it out again. So how to do that? IPv6 router OSPF100, then redistribute RIP followed by the keyword, then metric. Similar way for IPv6 router, this we have to configure in the configuration mode. IPv6 router RIP, let us enable the RIP in the configuration mode. RIPng is the keyword, then followed by the redistribute keyword. Redistribute OSPF, process ID, metric, and the metric value followed by the, we should not do the route map in case it is not mandatory. So these are the statements we have to do. And always keep it in mind, in IPv6 router OSP, always also you have to specify the router ID. So this router ID can be IPv4 address also. So these are the key points you have to understand. And another thing I want to show you is, go to PC1 and do a show IPv6. So you have to understand how it is getting the IPv6 address. So once it receives this prefix, right, this is a prefix I have defined. Once it receives the prefix from this interface, it will append the interface ID. So this last is the interface ID. This interface ID is generated from the 48-bit MAC address. So that's the thing I want to show you. So here only I have assigned the prefix value. Let us go to R1. I can show you show run interface fast Ethernet 3/0. So I only define the prefix. I not define the full IPv6 address. This is only it will receive the prefix, and in the interface ID will calculate using extended unique identifier. That is nothing but the 64-bit interface ID. It will generate from the 48-bit MAC address. That is the purpose of EY64. So I hope you enjoy this video. Thanks for watching. Please subscribe for more videos. Thank you and have a wonderful day.